So, welcome to all the audience and participants. So, day 2, 11th of November. Today, live, we're gonna be greeting key experts from leading companies, sharing their insights, hosting workshops. Let me tell you about what exactly is going to be happening today. At this stage, we have speakers from Sber, Yandex, Huawei, Intel, and Skoltech, the Faculty of Physics, and also the AIRI AI organization. All of these people will be sharing their insights, and of course, you are welcome to send your questions. All what you need to do for that is use your smartphone. Please do scan your QR code that we showed you on screen, join a special platform, and do send your questions. The speakers will gladly answer them. Of course, if we have enough time, but we truly hope that we will. And you will be not hesitating while asking questions. So, dear friends, let us start without any further ado. The first speaker, PhD in Technical Sciences, Deputy Head of the Center for Cognitive Modeling for Bauman Institute, the expert in AI competencies, Mr. Dmitry Yudin, and the leading expert on technologies for AI, the representative of Huawei, title sponsor, Mr. Andrey Kochetov. Dear friends, hello there. It's a great joy to present for you today at the iJourney conference. Let me also add that I am an employee for the Institute of AI AIRI. And today, I'll be mostly sharing the experience that our team has accumulated. I mean, the team of Bauman Institute in terms of training neural network models based on the new deep learning platform called Mindspore. Let me briefly tell you about Bauman Institute, what we do. The Center for Cognitive Modeling at the Fiztech faculty is mostly in charge of a wide variety of research for computer vision and cognitive robotics, automatic navigation and mapping, and that also includes automatic control, methods for automatic control, reinforcement learning, and behavior planning. I mean, a lot of things related to most contemporary AI tech. We pay special attention to neural language processing and intelligent assistance. Another thing that I would like to add, the experience of working with neural networks that we have shows us that, indeed, they are now solving a ton of practically applicable and hands-on useful tasks. Specifically in the domain of computer vision, we have a lot of advancements and developments for computer vision. Now you're seeing on the slide some very basic neural network models that are quite widely spread now for 2D object identification, for arranging those objects for 2D instance segmentations, and 3D object detection and segmentation. All of these models at the moment indeed allow us to build reliable, on-board, built-in systems for recognition of a road scene, for example, autonomous vehicles and intellectual robots that could drive within rooms and compartments, because soon we shall be using them more and more often. In addition, it's important to note that neural networks are now introduced very widely in tracking of objects. When, for example, you have discovered an object And it's not a static image or shot of an object, but you get the sequence of data that shows the tracking in LiDAR point cloud, for example, on the slide. We have been researching a lot in that domain as well. Indeed, neural networks allow us to improve classical tracking algorithms based on Kalman filters that used to dominate in the past in real hands-on cases. Also here, we are observing multi-object tracking based on a number of neural network models. Point track, central track, a lot of transformer-based solutions. Indeed, right now, they are especially curious. They do work, and we're actively researching them. In addition, forecasting of movement is another thing that industry is very much interested in. Everybody wants to understand where a human being would go, where a car would drive. And this is a task that is successfully solved with the aid of neural networks. Another thing where neural networks have only just arrived. This is mapping, markup, and localization. Neural networks are really novices here still. Their classical approach is dominating, like warp slam, based on identification of key points and optimization of position based on that points, based on classic descriptors, received thanks to classic approaches to computer vision. Indeed, here, neural networks can make a significant contribution. They allow us to quickly and sometimes in a more reliable way find these very key points. You may see here our robot at the faculty driving through the classes building trajectory, and SuperPoint and 2D2 LoveTech SuperGlue make a turnaround. Indeed, they start even replacing real classical algorithms. For example, DX, SLAM, simultaneous localization and mapping contains the aforementioned elements. Still, it's classical algorithms with some tweak of neural networks. And we actively integrate image search into localization methods, into Net Lab, when you can localize your position based on a photo bank. That truly does work today, much more efficiently than classical approaches. Also, neural networks are showing lots of advancements in terms of generation of some images or videos. Here's the example of how often these days these neural networks can be successfully applied to segment the shots made by drones or satellite shots. And it's also important here that on the fly it's possible to, as a matter of fact, render and synthesize the aerial view of this multi-channel HD card, HD map, and localize based on that map and identify the position of certain objects in space more precisely. These objects may be destinations or obstacles or walls that an object may hit. In addition, here, neural networks are actively being improved. We're researching them a lot at Bauman Institute. Another unconventional use for neural networks is planning of route. We have here different sorts of recurrent models. And reinforcement learning is now ahead here compared to classical planning. And the accumulated experience for neural network developments and different architectures and learning approaches shows that we have tried to put it together with a new promising platform called Mindspore from Huawei. This year we launched a joint project together with our Center for Cognitive Modeling. So now, together, we are developing and researching various models for deep learning and neural networks based on the Mindspore platform. As a matter of fact, this is another very contemporary alternative to all of the conventional TensorFlow, PyTorch, all of the popular frameworks. And we do observe that Mindspore eventually even is ahead of the mentioned frameworks. we compare speed and productivity for image detection and classification, semantic segmentation, point cloud segmentation, position recognition, forecasting of position in the video, even walking style recognition, restoration of images, point cloud segmentation that has been mentioned, some reinforcement learning, etc. We're seeing how they are behaving at this new platform that was introduced about a couple of years ago. So actively, it's getting now better and better. It's also an open source platform. It has a range of unique particular features, which make it very convenient and promising. And overall, these particularities show us that we have another efficient alternative, another great operable framework for deep learning that we can apply in real practice. Why? First and foremost, because there's a built-in cross-platforming nature. You don't need to install anything extra. There's eGPU, there's GPU support that we love, there's CPU support, there's NPU support, neural processing module that, for example, would include the new line of Huawei SCN. So this is a full cycle of all sorts of technological platforms that we normally apply within a single framework, where in config we change just one line and get the desired results. That is especially exciting. Also, the essence, the point of the idea of all the frameworks for deep learning is efficient work with computational graphs. It's made so that we would be able to work efficiently with the methods of gradient optimization. This is a core for any framework of deep learning. And Mindspore puts together specifics of static graphs in TensorFlow and dynamic graphs that are in SpiderArch, and everybody likes them. And this platform represents sort of a unity, and the specific feature of Mindspore is, of course, application of methods of functional programming to aggregate all these advantages of approaches. So, this sort of framework also has a particular feature. I mean, it's automatic parallel approach for distributed learning. You can have a number of CPUs, a number of GPUs, or a number of NPUs. This will work, and this will be more efficient. We'll talk about that in more detail later. A huge library of existing models. And again, there is the original version for Mindspore repository. It's available at GT, the Chinese resource, and there's a mirror of this resource at GitHub. As for models, it's a zoo. There are a ton of implemented models to analyze and recognize audio, computer vision, graph models, new natural language, and there's official research here, somewhere perfectly developed, somewhere in research mode. Now we're doing a lot of work there to increase this range of models. We are conducting research on quite a vast class of neural network models, trying to integrate them into this rich storage. So, another thing to highlight, this is a very new framework, and before we begin using it, we need to compare it, whether it gives some sort of profit or not. And turns out that on this slide, for example, you may see a number of backbones that we naturally use to classify images. Overall, that can be used in different solutions by all means to analyze images or videos. And here we may observe that, as a matter of fact, the models trained with Mindspore and the original TensorFlow-based models show pretty much similar level of quality, but eventually Mindspore is even ahead, allowing to teach the model, train the model even better. But in my opinion, we do observe here that we can trust this new framework, and we can truly use it for a broad class of neural network experiments. Reach documentation is also there. We have been using to update it. Indeed, we see that this framework is clear and accessible. So pretty quickly, we can transition to using it if you need to apply its capabilities. On this slide, I wanted to show you that the particularity of this solution the zoo models of Mindspore is reproducibility of a code. Every model is reproducible. That is actually kind of the good behavior. This is a decent approach. Everything in charge of testing, deploying, etc. All of the models are there, and over here you can just download and try it. Always, when you study a new framework, you are trying to rely on what you already know, what you know how to do, and now PyTorch is in the lead globally. Most of the papers regarding AI and ML are based on PyTorch framework. If we talk about battle between PyTorch and TensorFlow, PyTorch is ahead. Mindspore has been able to put together the best features of PyTorch as well. Please take a look at the still code listings for segmentation model, DeepLab v3+, and indeed Mindspore is very similar in terms of syntaxes to PyTorch. So if you are specializing in PyTorch, it will be easy for you to migrate to Mindspore. Okay, next. Another thing to highlight, there's the visualization tool. When you train a model, we're all used to applying TensorBoard, widths and biases, but here in Mindspore, there's a convenient tool, Mind Insight, which allows to use the tool that is just as convenient to save the history and the detail of learning. What images were in the process? What tensors were used? How can we see and observe the computational graph, the distribution of parameters? Overall, it's a convenient tool. Vitaly Bezugli at the next workshop will probably show in more detail how to use it. And another thing to highlight is, here's the example, visualization, which is very conventional, very evidential. And here's what I want to point out at this slide. This is training on a single GPU, RTX 3090. And wide ResNet image classification, and you may see that it's pretty confident. Quality up to 1.9603, 96%, which is top 1 precision. Let me highlight as well that it's good to have one GPU, but we want to use a ton of devices, right? And Mindspore implements this very convenient parallelism. Here's one of the aspects that of the parallelisms that you may see. This is parallelism of data. So if we use this sort of parallelism, there are a number of copies of the model, n number of models, and they are all trained simultaneously. So your batch of data, which you're hitting your data set into, it's broken into mini batches, and those mini batches are sent to the n copies of model. There are gradients calculated, and practically they are then aggregated based on the all-reduce operator. And then we get this aggregated gradient, medium gradient, which is sent to all of the models simultaneously. And we may include synchronization of the weights, synchronization of parameters, broadcast parameter in this particular case, and therefore you get the improvement of propagation and better quality of the final result. It does work. At this scheme, you may see that visualization of different devices that work in different streams. We improve convergence. On one GPU, we will launch one model, and you may see that they behave practically the same. And you see the precision here is, the accuracy here is 9612, 0.9612. So if we add one more computational unit, you get better quality. That's a nice to have. That's a built-in thing. And indeed, this parameter you change only with a few lines of code, which is, again, very convenient. It's integrated. That is one of the very useful properties of Mindspore. On this slide, you may see how we can visualize inference, how we can visualize all of the output tensors that your model outputs, all of the images. For example, you can see here the probabilities. or the degree of confidence for a class. Somewhere, of course, the model does make errors. Sometimes it's completely correct. I would like to highlight that overall, our first experience working with Mindspore is only recent. We began working with it only 4 months ago. And as a matter of fact, we observe that this is a very, very convenient tool. It's very convenient to work with it. It's especially convenient to start with. We will continue our research of this tool, and we will be sharing the news, the instructions, making workshops. We have decent experience with that. We love sharing our knowledge. And I would like now to hand over the screen to my colleague from Huawei, Andrey Kochetov, who will tell about the fact that Mindspore is only a part of a vast Huawei ecosystem. Hi there, you guys. My name is Andrey. I am the engineer for Huawei. Dmitry, thank you so much for the intro into the platform, Mindspore platform. As Dmitry has correctly noted, Mindspore is a universal platform. So it can work based on CPU, GPU, and also the Huawei Atlas platform hardware. So let me tell you about a few technical details about our Atlas hardware platform. On this slide, you can see entire Huawei ecosystem for AI. On this slide, there are collected all of the major components of the system. And if you look left to the right, first and foremost, we need to mention Da Vinci architecture. Da Vinci is a special sort of architecture specifically for neural networks. It's based, as you probably know, massive matrix multiplier and vector scalar units, memory controllers. This is a crystal-on-a-chip system that's been produced by Huawei. This architecture is special because all of the Huawei products are based on this architecture, meaning this server-based solution, the edge stations, mobile devices, they all work based on Da Vinci architecture for AI. So, in order to produce server-based solution, there are two crystal-on-chip systems, Ascend 310 and Ascend 910. 310 is positioned for inferences for deploying networks. This is the optimal solution in terms of power consumption and productivity. Ascend 910 is maximum productivity when you don't care about power consumption. Let's look at the center of the slide. These are products for AI, top to bottom. Edge stations, edge devices, Atlas 500, that can be installed right there in the street or at a production facility. It can be work at minus or plus 50 Celsius. And it can do video analytics. We have also cards for inference and training and a module, Atlas 200. You can use it to build your very own device, a drone, a smart camera, or anything like that. That is sort of a constructor block that you can use to build your very own device. Also, we have servers, by all means, servers for inferences and servers for training. There's the Atlas 900 cluster for training. I will tell it in a bit more detail. And let's look at the right column. In terms of our software stack, first and foremost, we are expanding the community actively in Russia. Many thanks to our colleagues from the Bauman Institute. We are very grateful to our colleagues from other leading educational institutions in Russia. They're testing our solutions and technologies. This is awesome. Therefore, we have Model Arts platform that is a cloud solution where developers could use cloud to launch networks, neural networks, experiment them, test them. That's available in the cloud. Also, there's framework support, as Dmitry said. There's Mindspore, which we're actively improving now. And the mission of Huawei is to make it even better, so that it would be especially flexible and easy to use, and would provide good productivity. Also, we are supporting the well-known frameworks PyTorch and TensorFlow. We are also developing our very own SDK, a set of libraries that helps us to solve and facilitate tasks in particular domains, like production, or object detection at a production facility, or production maintenance, and of course computer vision. All of the tasks related to computer vision. This is simple because you can use blocks to create your very own app. Also, we have a low-level set of low-level API based on Python and C++. It's called CAN, which helps you to allow your model to launch your model for inference and for training using our very own hardware. So, if we look particularly at this project with Bauman Institute, we suggest using the Atlas 800 AI server, model 9000. This is a special sort of server for training. Here's the insides of the server. It consists of two major motherboards. Below, that is the accelerator board, which has 8 neuro accelerators Ascend 910 connected to one another. And on top, there's another motherboard. This is the general use CPU for Kumpeng CPUs based on ARM architecture. All of them developed by Huawei. So this sort of server can actually give you 2.24 petaflops with the FP16 precision power, and it consumes 5.6 kilowatt, which makes it actually one of the most attractive solutions in terms of productivity and energy consumption and space in the data centers. It's a 4-unit server. We can make a very tight rack with high productivity. In addition, every neural accelerator has hardware interface, 100 gigabit internet and RoCE interface, which helps to connect 8 chips within a server and connect them to external servers, so we can build an entire cluster and train through the distributed network using a number of servers in a cluster. A few success stories. We're actively improving our facilities in Russia. We're open to cooperation with the educational institutions and businesses. And if I have to give you an example of Chinese success, the Pancheng laboratory in China, they built a cluster of these servers that you have just seen on the previous slide. And right now, this is 1 exaflop of computation power for the time being, 2020. And now they're going to expand the server that is 16 times more powerful, 16 exaflops. So what sort of what sort of tasks they are solving? They are doing Chinese language learning. They're processing over a terabyte of data, and 1048 Ascent AI processors are used to teach Chinese language. There is an open article, the link is below, to learn about this experiment. So it's a large-scale model training on Chinese language, and they're using Mindspore framework that we have just been talking about. And this cluster occupies the first positions in the iPerf 500 rating, IO 500 rating. I mean, this is open information. You can easily find it online and check for yourself. Consequently, national Chinese program builds a range of these centers all around China. But we are ready, by all means, to opening similar centers in Russia. We're now negotiating with businesses and educational institutions to provide the sort of computational facilities for researchers and scientists. I've seen a number of questions online. I think we're ready to answer them. Indeed, we have a number of questions from our audience. Let's try to figure them out. Who wants to be first to answer the question? You can do it together. So, what's the biggest advantages of open source software? Why more and more IT giants developing open source environments? By all means, the major motivator for this is the community that for free will find all of the errors for you, that will for free develop a ton of modules. Yeah, they will be not as perfect as you would want, but indeed, they will try to develop the products that will be hands-on applicable, and that is beautiful. That is truly beautiful. That's why this is the future. As for commercial objectives, these open blocks, either a company itself or somebody else may advance and use it for sale. I mean, that is a decent business model. Everybody's doing that. And all of the successful companies are now using open source. As for Huawei, Mindspore is an open framework, and it's important to show everything evidently, what the framework is made of, so that there are no secrets and everybody can try and test that. And maybe make contribution to correction or improvement. I mean, we are very much interested on behalf of Huawei in that. Okay. Another question, does the infrastructure of platforms support third-party neural processes? And if yes, how that was implemented? Neural processes, okay. Yes, indeed. Third party. Okay, Mindspore, it's more about software. So Mindspore is a framework, supports 3 types of platforms. That is general purpose CPUs, GPUs, and of course NPUs of a SAND class for the time being. But of course, we are looking ahead to add newer processes, seeing who may join Mindspore. We're hands down in favor of expansion of the platform. Thank you, dear colleagues. Thank you so much.